The directions in this section say to evaluate the improper integrals, which means there will be some sort of limit or discontinuity that we're going to be looking for. Right, in the first one, when we're evaluating the integral of 1 over the cube root of x minus 8 to from 8 to 35, I notice that 8 is a discontinuity. So we need to reset up our problem. I'm going to call that a to w. We're going to rewrite this as the limit as w approaches 8, and since we're going from our defined point down here, we will be approaching it from the right side. So we're going to approach 8 from the right side, and then we will still have the integral. Will go from w to 35 of 1 over cube root of x minus 8. All right, so now let's go ahead and just evaluate that integral. I'm going to do a u substitution. U will equal x minus 8, which means du will equal 1. I have that, so when I go to rewrite that problem, this really will be a du over u to the 1/3. So if I rewrite that, that will be u to the negative 1/3. And when I take the integral of that, if I add 1 to my power, I'll get u to the 2/3 and then a 3/2 on the outside. So this will actually give me 3/2 x minus 8 to the 2/3, and then I do get to evaluate it at 35 and w, and when I go ahead and plug 35 in, I'll get 3/2 times 35 minus 8 is 27, so I have 27 to the 2/3, and then minus 3/2 w minus 8 to the 2/3. Alrighty, so on this one, 27 to the 2/3, let's do the root first. The cube root of 27 is 3, 3 squared is 9, 9 times 3/2 is 27/2, minus 3/2 w minus 8 to the 2/3. From here, we have our integral as far as we can, so we will now be finding the limit as w approaches 8 from the right. Alright, so when we do this, we'll get 27/2 minus 3/2, and now since I'm finding it as approaches from the right, if I plug in 8, I will get 0 as an answer there. So my final answer will simply be 27/2. Right, next one, we've got the integral of dx over the square root of 9 minus x squared, evaluated from 0 to 3. I notice that my discontinuity is happening up at 3. So we will go ahead and call that w. So we'll change our problem. We'll actually be finding the limit as w approaches 3 from the left side, because if we're going from 0 to 3, we're coming in from the left, and then it will be the integral from 0 to w of dx over the square root of 9 minus x squared. All right, I notice that is an arc sine problem. My a would be 3, my u would be x, my du is 1. We're all set to go. So this is going to be arc sine of u over a, so x over 3, and I get to evaluate it at 0 and at w. So this one is going to be arc sine of w over 3 minus arc sine of 0. And I know that where does the sine value equal 0 is at 0. So this is simply just the arc sine of w over 3. And then once we've evaluated as far as we can, we still want to find the limit as w approaches 3 from the left. Well, I notice if I plug in 3, I actually can't get an answer, so I really don't care it's coming from the left. So we'll get arc sine of 1, and we think to ourselves, where would the sine value equal 1? And that is at pi over 2. Okay, problem 20. We've got the integral of e to the x over 1 plus e to the x. We're going from an infinite, negative infinity to infinity. So this is one we're actually going to have to split up. So we are going to find the limit as w approaches negative infinity. And we'll go from w to 0. Of e to the x over 1 plus e to the x, and then plus the limit as w approaches infinity of 0 to infinity. And remember, you can pick anything you want. I just happen to pick 0 because I could plug 0 in here, and e to the 0 is 1, so I figured out things would probably work out nicely when I went to evaluate it, so that's what I did. Alright, so we've got them separated. I'm going to go ahead and tackle this first integral first. I noticed that I could do a u substitution and let u equal 1 plus e to the x, because then du is going to equal e to the x, which I have. So this actually is just a du over u problem, and the du over u is just the natural log of u, so the natural log of 1 plus e to the x. I now get to evaluate it at w and 0, And so when I do that, if I plug 0 in, I'll get ln 1 plus 1 minus the natural log of 1 plus e to the w. And then from here, that will just be the ln of 2 minus the natural log of 1 plus e to the w. So this is evaluated as far as I can. So now I'll find the limit as w approaches negative infinity. So when I let w approach negative infinity, I notice that I get e to the negative infinity, and e to the negative infinity is actually 0. So I'm going to get the natural log of 2 minus the natural log of 1. So my answer for this part will be the natural log of 2. And then, excuse me, for this part we'll be adding, when I find the integral again, it's the same thing. So I'll get the natural log of 1 plus e to the x. This time we'll be going from 0 to infinity. And when I plug in, whoops, no, we will not. We're going to, I should have put a w there, w. So I'll get the ln of 1 plus e to the w minus the natural log. That will end up being 2 again. And then this is as far as it can go, so we'll find the limit as w approaches infinity. So when I do this, I'll get ln of 1 plus e to the infinity minus the natural log of 2. And so when I do that, e to the infinity is infinity, so this actually ends up being infinity. These two actually end up canceling out, so I get infinity as my answer. So this integral diverges.